Oh, hello. Oh my. Oh, is this gonna be the first time that what is it gonna be the first time that like everything's like worked? Oh, something's got to go wrong. What's this? What is going on? I'm looking around. I'm sort of trying to find. I mean, I've got music. I've got audio. Well, I started when I said I was going to start, so the countdown worked. Whew, blimey. I mean, stepping up here. This is a new game. Wow. But there's probably no one here. So you can't win them all. So yesterday we were working on. Let me just pull this down a little bit. There we go. Yep. Let's move this across because that's what we did yesterday. So what we were doing yesterday was... I'll bring it down a little bit. I mean, I don't know how high it is in the audio, but I can hear it. It's a little bit annoying for me. So, yeah. Oh, I flipped my mic round. I found that it's potentially why I keep getting all my keys wrong. And I headbutted it then. But massive wink, it's probably not. But I'll use that as an excuse for now. Maybe, no, that's probably enough, isn't it? We can see everything. Let's have a look. Yeah, we can see everything. What was the other thing I was going to do? So we got to accumulating values. So where do accumulating values? And actually, I'll do a little recap what we did. So yesterday, firstly, we just well, we did a bunch of other bits and pieces about the do blocks and grabbing bits and pieces out when dealing with here. So because this becomes in a maybe monad inside, so we can grab the values out of running. You know, we can do functions in a sequence. So we can pass the input into my func1. Let me just shut that up for a little bit. Yeah, and then the output we bind out of it to get the output, and then we pass that to my func2, and we get the output there, and we pass the output. So yeah, every time we're binding out. And then we started making our own maybe monad. Monad maybe. And then we went on to do the either. So to do a monad, you can't, you have to do it all the way through basically. So when we were going, do an either monad, but really as soon as we did that, it says I want an applicative, and as soon as we did the applicative, it wants a functor. And then we went over how to make them, and in essence the idea was that these types, or when we create instances, so we have like a data type up here, and I'm just going to recap because you might as well in case you missed it, and it's good to iterate, keep going over stuff, and then eventually it'll sink in. Well, that's what I'm hoping anyway. Well, it kind of has for me, but yeah, for people listening. What was I going to do? I'm going to change that. There we go. So I can just see. So the idea being is we have this type. It's just literally it's a copy of either, and when you know its constructors are left and right, meaning that when we're using it and we pattern match over it, it says, well, you can either use left or you can use right. And then what we want to do is we want to be able to do things like fmap over it. So if we do an fmap, it's just the ability to, if we look at the date, hold on, will it show me? No, don't do that one. Docs. There we go. So if we look at the type of fmap here, oh, that's like, I mean, yeah, it's basically, oh, that's nice. Does it for you to constrains it to either. That's nice. So the fmap is basically we give it an either A1 or A, so that's either left or right, and then we've got a function that does an A to B, and then it will return us an either A1 or B. Okay, so we want to be able to, so this is basically like mapping over stuff, but in this scenario we're mapping over either. Okay, and then what it says here is fmap obviously requires that function from A to B, and then if we give fmap a left, it's not even going to use a function because it's going to act like this is a nothing. But unlike nothing, we're going to pass along the A. So if we try and fmap a left, we're not going to be able to apply that function to it. We're just going to return the A wrapped in a left. And then if we fmap the right side, then we'll find that that's an A to B, and there's our A. So really, we want to return again an either, and that goes A to B, and then this needs to be a B. So if you look at fmap again, not that one then, this one, yeah, you see it'll return either A to B. Well, actually, if we, also showed like a nice little type holes, which is always nice. So I'll do that. Type holes, there we go. So it requires to be either A, B. So we're dealing with right, so we'd go, okay, I'll give it back a right. And then it tells us, oh, I should point out, I'm reading this part here in red. And it found a hole to be a B. So then if we expand our errors, when we get back, it's a little bit hard when you've got, you know, the font's so big. But it shows you, type hole shows what's in scope. And if you look, we've got an F, so that's referring to that. It's an A1 to B, cool. And well, we want this to be a B, and we've got an A1 and we've got a function that goes A1 to B. So obviously we're going to use the F, well, we're going to pass F the A, and that returns us to B. That's basically all it's doing. So anytime we end up using fmap with our either tick, then this is how it's going to, you know, this is how it's going to work. So we're just telling the compiler we want fmap to work like this in this specific scenario. And then the same with applicative. So same again. Wow. Hold on. Yeah, it's like, it's good, this documentation, until it's like that, and then it's not so good. Am I pressing disabled? Yeah, there we go. So now we can go. It's much the same. So applicative with left. Sorry. So the extra thing of applicative is we get a pure. And pure, what it means is it's going to wrap the either into a context. So you'd have, it's actually pure A and it return right A. But because of currying, we can just leave it. So the A just boop, automatically jumps into there. But you don't have to do it. If you don't declare it here, it'll automatically add it to that. So that's why you can't see an A. Then we've got a left of E, which we know the left of everything is going to be like an error. It's like, no good. So when we apply it to, doesn't matter, we're just going to return left to E, because that's when it sort of fails. It's like, no, return left, and then with an E. And if we go right, then we've got our right of F, which is our function inside of right. And then we're going to put it onto R. So let's have a look. Let's have a look at what things are. Actually, I could probably just hover over them. It'll just tell me. No, it won't. Oh, it would if I was to. Oh, it doesn't matter. We'll look in the errors. Where are we? Oh, I need to bring up some more. Yeah, I need. Maybe. It's kind of alright for the font size, isn't it? So I can't really bring it down. But anyway. So here it'll tell us that R is an either A1 and our F is A1 to B. So somehow we need to access that A1 in the R and pass it along to F. Well, we know if we fmap above on something that's on the right, it's going, which is that side, that's where it's going to return us, isn't it? So what we need to do is to access that. We need to fmap over it. It's exactly what we're doing. So we're fmapping over our R and passing it to F, which then returns us a B. Yeah, does that make sense? I think it does, yeah. That's not too bad. If I can grab this going down. So yeah, here would be an R. Cool. And then now we're getting into monads. So at this point, what we're doing is we're doing a monad of either A. So we'll use return, which is exactly the same as pure. So we're just saying wrap it. If you look, exactly the same. Boof, boof. Okay. And then we do a left bind to whatever. Again, all like the others, like the functor, applicative. The left is just going to return left with the L, because it's the wrong, you know, it's the error. And then the right bind to F. So if we look at the types of R and F, so if we look R, is A1. Okay, so whatever so basically we're using a monad to get rid of, we're getting the R out of right in the type here, and then we want to pass it to F. So if you look at F, that takes an A1 and it returns us an either AB. And then so that obviously is what we're passing along. We're literally giving the R to F. Okay, and if you look at our type, that's exactly what it does. But what I'll do quickly is if I do also this, we'll see here the hole's either AB, where B is rigid. So we know that F and R, that's what it's doing. Right, so that was that little bit. And then it continues. Where does it continue? So we went into that. Oh, and this was like type, look at this, right? And then we kind of like went a little bit mental. So this is code. Don't worry about what it actually is, but so we can save that there. Okay, so we've created this type. This is really like, it's beyond the scope of this, but it's worth seeing. So we've created we've created that type there, and we've created another, just a set of type. And watch this. If you're to attempt fill hole, bloody does it for you. What sort of a voodoo magic is that? Yeah. So I was showing that yesterday. Bloody impressed. That's what I was. What am I doing? Here we go. Yeah. Okay. So that was like a demonstration. Oh, and I've got the Haskell language server installed. So that's where all this stuff is coming from. So if we look at like print, for example, and I'll load up the docs. Can you see like it's all over, and it just shows you like the docs for print. So print is a show, it's constraint of show A, so it's A to IO, and that's what's printing. I'll turn it off because it's good when you've got the screen in normal resolution, not sometimes so good when you've got it like this. But that's really handy because you get to see all your types, and also if you hover over things, actually I'm going to show it again, it'll tell you what type the env is. So look, env is an environment, which is right at the top here. So you can sort of find out string. What's the type of string? str. It's going to be string. Yeah, so that's quite cool, isn't it? So you can find out. You can do that, or if you haven't got it installed, you can use type holes, and then like I do here, you get to see the errors in here. So yeah, and another thing I'll go over again is don't see the compiler. Oh, I don't know what I just disabled. LSP UI disabled, enabled. Okay. Does that mean I've that's 1 second. Yeah, there we go. I just didn't want that. Yeah, so if you're using type holes and the compiler, the best, I mean, the number one thing I should, that I want to iterate is the compiler is your friend. Because I spent potentially, I don't know, maybe 2-3 years being annoyed at the bloody thing, going, ugh, why can't I get it right? Why aren't you, why do you keep telling me I'm doing it wrong? But once you sort of change that mind frame to the compiler's actually there to help you, then it starts being fun. So you'll see as I sort of type things in, the more I type them in, I'm just using type holes going, okay, what does it want here? What should it be? How can it help me to write this function? Which is it's really, really handy. And then here we just demonstrated that instead of the ability, because we're in a monad, so if we have a look, does it give us the example? Yeah, it does. So it's saying it grabs a load env, which for us is just an environment. So what we're saying is instead of giving it, we're still using let's have a look. Are we still using, oh, it doesn't show you. The problem was, I'm trying to remember what the problem was. I think it was passing all our values down, to get, so if you look, oh, it's not in this one. Was it another one we did that? I think I'm thinking of a totally different, maybe I was, don't know what it was. Let me try and look. So it's basically we're saying we've got an environment. Yeah, so it looks like it, doesn't it? Yeah, I think that one of them became, I can't remember. It's up here somewhere. Look at that. Yeah. So was it the reader solution? Is that right? Let's read it quickly. The reader monad solves this problem effectively. Creates a global, yeah. Oh, is this? Hold on, we're not in reader yet though. Where? Global variable. Did we just? Ah, is this what? Oh no! This, yeah. So the problem here is solved here. Let's have a look. So here the problem is we're effectively passing things along. So if you look at this, yeah, I didn't write any of this down. But the idea is you've got an environment data type, okay, and then we're going to use that very much in the same way as as we use an either. So the idea being, sorry, it's not like an either at all. It's a reader. Yes. So the idea being is we've got this, which loads the environment from the outside. Okay, so IO. And it returns us an environment, so it doesn't really matter what happens in the function. We'll just look at the types. And we've got function 1, okay, and that takes an environment and then returns us a strict. Function 2 takes an environment, returns an int. Function 3 takes an environment and returns a float. And the problem with this being that if you look, it's actually going from function 1 environment, but really the place where the environment's actually being used is only in function 3. So what we're having to do, we have to we're passing this environment around. You see, look, it goes environment, env goes into function 2, and then env goes into function 3, and then at function 3 it's being used. It's kind of like a bit redundant, you don't want to be constant. Can you imagine if you've got like a code base and then you're actually passing the environment around through all the functions, like back and forth? Whoo, nightmare. So there was a reader solution. And then what that says is you get on reader, you get a function called run reader. So that'll grab the value out of reader, which is a reader monad. And then you get another one called ask. Okay, and then what happens is all the types, they turn into, so if we looked at the previous one, they were like environment int. Well, so it's that one, yeah. So it's reader environment. So that would be the reader that its environment, and then its return type is int. Okay, so that becomes the reader monad. And then what you can do is in here, you're still in it, but you can pass things down. So let's have a look. Function 2 that asks, function 3 that needs the environment. So what we're doing here is we can literally just left bind our result, which would be an int. So if we were to look at the type of that would be int, and then we're just passing int to there. And then really, so we're doing all this stuff, but these two still stay the same, and then the only one that actually uses it, so we're not passing it from here, we're not passing all the way through to get to here, we're just keeping them into the reader monad, so these have access to it, and then when we get it, we then pass it to function 3. So I mean, technically you could also have it so function 3 just grabs it, but whatever. Yeah, so the ask function unwraps the environment so we can use it. Cool. The monad bind action allows us to glue different reader actions together. Yeah, so that's good. And we also need to do, it's called a run reader function, and supply the environment as a parameter. So yeah, this is when we start it off and it wants the environment. Yeah, so that's that. What is there? It might not seem like we've accomplished much, but our code is much more intuitive now. We keep function free as it was. It makes sense to describe it as a function from an environment to a value. However, our other two functions no longer take the environment as an explicit parameter. They simply exist in context, where the environment is a global variable. Cool, and then here we go. We're now to where we were going to start. So if you've watched the previous one, you're watching this one again, it'll do you good. I'm going over stuff. It's good for you. Accumulating values. Now, to motivate the writer monad, let's talk about the accumulation problem. I think it's like in the Haskell book. Basically, you don't really end up using the writer monad that much. I think that's what it says, which is true. Yeah, hi, by the way, Hal7. Yeah, it should be reader T, but what we're doing is we're getting to that because T is a transformer. It's a monad transformer, and we're still in the monad area. So what we're saying is we're showing, I think the idea is they're going to show reader, and they're going to show write, and then they're going to show, you know, the T version, the transformer version of it, which basically sort of combines them, doesn't it? Which this doesn't. So I think that's the idea. Yeah, I think that's right. So now to motivate the writer monad, let's talk about the accumulation problem. Suppose we have a few different functions. Each will perform some string operation we've assigned to an arbitrary cost. We want to keep track of how expensive it was for the full computation. We can do this by accumulating arguments to keep track of the cost we've seen so far. We then keep passing the accumulated value along. Cool, so let's have a look. Calls func2 if even length, func3 and 4. Okay, so if odd, is this like, I guess? Okay, let's try and work out what it's doing. Oh, this is sorry. I was reading that as like a new line, but it's actually wrapped around from here. So func1 it just takes a string, returns a tuple. So if it's even in length, then func2 and a tuple. Otherwise, do some stuff. Where are these getting these values? Oh, and these values, which is getting them from the func3 and func4 of passing a 0 and a tail of input and the head of input, it looks like. Okay, so yeah, it's not really storing much, is it? Let's keep going. Actually, I should probably just copy these down, so then we can get some types, because going back and forth might become a little bit painful. And also we'll get to see it in colour. No, we're not stuck in the 50s. We can have a little bit of colour. Oh, there's lots of functions here. Function 3. And it's good to go over things like that, because then you can understand the functions in full. Except I've inlined this wrong. Okay, let's see. Any errors? No, it's happy. Wow. Okay, wasn't expecting that. Let's, for one, close that, and then close that too. Just a little bit of extra room. And of course it's going to complain because I've got loads of func ones. So we're going to go. What are we going to go? Yeah, everything's going to be 0. Func 20. Func 30. Funky. Cool, and then obviously these are gonna. Oh, it's gonna be. Why did I do that? No, I'm gonna keep going. I can do a replace, but I can't remember how to do a replace from a specific area. So if I do a search and replace, I can always do it on the whole file, and that's probably not at all what we want. Where was another one? I think that's it, isn't it? Yeah. We happy? Yeah, we're happy. Happy, happy, joy, joy. Cool. So, func 10, yeah, so it checks if it's odd or even. If it is, then it just returns that, which is there, which is func 20. So if we look at func 20, that takes a tuple, and if the length of the input is greater than 10, so I think it looks like it's going to accumulate that 0, isn't it? By the looks of things. Yeah, so func, oh my god, so it just basically it's passing things around, and every time it's passing it to another value, I think it's gonna add 1 to it by the looks of things. Wow, yeah, how should we start it? Pass it a string, so it wants to be something that's above 10, and I don't know, let's just try it. Let's see what it does. Control C, Control R. So I'm just opening up the REPL. Gotta wait. There we go. No, it's gonna ask me about removing things. Do I want to remove them? No, just keep them, please. And we're gonna load journey. There it is. Yep, that's fine. And then was it func 10, wasn't it? Func 10. And we're going to pass it a string and above 10. Hello. What's this then? 10. Hello world. How many characters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Don't type it. That's basically just gone straight and returned the first value. We want it to go a bit further, don't we? Hello, my mum. Oh, why? Is that exactly the same number? No, it's more. Okay, should we just do a bigger... okay, I'm not going to make... I'm going to do it, so it just makes absolutely no sense. Is it above 10 or is it below? Hello. So what happens if we do hello? Ah, there we go. Oh, look at that. Okay, so that's like flipping things around and getting rid of the E and doing all sorts. Okay, well, let's not worry exactly about however. So, however, an int isn't the only type that we could accumulate. We could instead be accumulating a list of strings. So it looks like if it's got to 2, I guess it's gone through 2 functions. We could instead be accumulating a list of strings to print out, print as a log messages, so we know what computation will run. Okay, monoid. Yes, a monoid. Oh, cool. Hey, how's it going? One hell of a journey. It sure is. How's it going, Gil Christian? What was I going to say? Oh, look, you've got like the CV lad wave. That's pretty cool. Yeah, we're just going over this stuff. We're on writer, monad. So we're nearly there, really. We're nearly getting to the monad transformer. And what's happened is we've got these functions that seem to do a bunch of stuff. We're manipulating. It starts off with a string, and then they're passing around the tuple. And it seems that the tuple at every point, if it goes into another function, it's going to add like 1 to it. So it shows, and then we just ran it just to have like a little look at what's going on. Func 10, and then we passed it, and that seems to have gone through 2 functions like that. So yeah, what's this? 1, 2, 3, 4, 5. So what if we do? I mean, I could just read the functions, but I mean, it's much more fun just passing it till something. Whoa, 10. Okay, well that must go through a lot. Hell literally returns as 10 in hell. So yeah, something's accumulating and it's gone through a lot of things. Because if we look at the previous one, we gave it 5, and then it kind of like swapped things around and only went through 2. But here, we return a 10. So it's saying that we can accumulate values, and then to do that we can use a monoid. Which, oh well, it shows you what the class monoid is. And we can see it in use actually. If I, oh, we've got it here, haven't we? What would be a monoid? Can you? No, hold on. I'm doing stupid stuff. Let's see what happens. Yeah, oh, certainly not A. This isn't going to work. No. So we can do this though. Is it? I can't remember if you can do that. Oh, someone's. Yes, you can. There we go. So we're literally going. This is how monoid. If we look at the type here, it's just going A returns an A. You know, like when you're unsure of yourself, you're like, is it really how this works? Just didn't trust it for a minute. It's like, yeah, that's not how it works. And the same where, because this is a string as an array of chars, you know, you can go hello world. There you go. Magical. Yeah, see, and with monoids you get a memty, which is just an A. So, you know, that would be one for lists. Okay. Mapend, yep. So mapend is literally what we just did. It's that. Oh, can we run it actually? See, look. Like that. Yep, there we go. It's exactly the same. This is just the infix version of it, but it's exactly doing the same thing. So that's our first value, second value. Cool. So Yeah, so an instance of monoid on int. Yeah, so monoids, you know, it's the same as when we were doing instances of either, and we sort of went through functor, applicative, and then we did monads. Well, monoids have instances too, and one of them, well, yeah, we can give instances of monoid to int, and then the ints one of mempty is 0, and then mapend in it is like a plus whatever. What happens then? 4, 5. Yeah, not going to be happy there, are you? So why doesn't... Because that's kind of like exactly what it's doing, isn't it? Hold on, what's it returning? Monoid. Not going to question it. So our accumulator starts at 0. Why doesn't that work? Oh, we need to give it a type because it doesn't know, doesn't it? So that's probably right. Don't do that. 4, 5, and we'll go to int. If I spelled it right. Monoid int 4, 5 mapend. I have to give. What do I have to? Oh, I'm not going to do it. No, I think I'd have to give it. No, I'm going to do it. It can't be like this. Maybe I have to give it to 1. No. No instance for monoid int. Oh, okay. But there is. Oh, hold on. Oh, you'd have to make one. Force a type. Force a type. How do you mean force a type? Like, just type in force. No. Check. I thought I did force a type. Oh, when you do at, whatever. Is that what you mean? Oh, we just think, yeah, okay. Oh, that's weird, isn't it? I mean, what we'll do is we'll move on because clearly we're dealing with a more complex subject. Let's not worry about that. I'll just scroll that up there. We'll press enter a few times. There you go. Never happened. So the writer monad is parameterized by some monodial type. Its main job is to keep track of the accumulated value of its type. So its operations live in the context of having the global value that they can modify in a particular way. We can change our code examples above to use writer monad as followed. Okay, we can do that. Let's do that. So func1, let's see what has changed. That seems the same. Oh no, here we go, look. So we're doing run writer and we're passing in. You know what we should do? Yeah, this is the reason why you don't really use writer monad, but we'll have a look. Run writer. There you go, it's got a monoid. Whoa, zoom in. Where are you? That's kind of big enough. I'll make it a little bit bigger. Yeah, so writer. So it's the constraint is monoid on the W. So writer, that's a monoid. Yeah, so that's like the value that we're going to store, and then that's going to be unwrap the writer computation as a result and output pair. Yeah, and then it returns us a tuple. I think that makes sense, doesn't it? AW, and then I guess is where we can. So that run writer. Oh, okay, yeah. So that's literally run writer. Sorry, I'm being an idiot here. No, negative. Not an idiot. You're not being intelligent. Oh shit, it's the same thing. So, oh no, what have I done? Go back. Here we go. Yeah, it's literally just grabbing the W and the A and returning a tuple. I was looking more into it for some reason. So that's what our run reader does. So in here, yeah, so it's looking, so that's why, yeah, so that's how we can return a string and an int. So if we run reader func2 of input, it'll return us a tuple string of int. And then run writer. And if we run writer do, then it looks like, oh, okay. let's just grab this, because I think no, we want to grab that bit, don't we, of the then. Because what we can do here is we can oh, it's probably going to break, isn't it? But yeah, I thought it might do. Oh well, first and foremost, oh, and then I'd have to import everything. Is it going to say I want it? Is it say I'm going to define? No. No. Oh. Okay. Oh, I'd have to import it all. Scrap it. We'll just do it by visuals. Because I'm being lazy. Okay, so it seems then, so let's compare it, okay? So that's exactly what it's doing our first one. It's literally, look, it's func20 and the input, except we're passing 0. So in here we're passing a tuple around, but in this scenario we're sticking it in the run writer. Well, we'll use run writer. So let's have a look at func2. So func2 just expects a string and it returns us the writer monad with an int and a string. So let's have a look at our output then. So if, let's compare them. So we're just, at the moment here, we're just literally passing, before we were passing the integer and the string, but here, look, we're just passing around the string. So the integer's been stored somewhere. So if the length of input is greater than 10, then, and this is because we're inside a functor here, so we can go do tail 1. Okay, I think tail, I'd assume, is, maybe they shouldn't teach you stuff about oh, I'm trying to find, actually, if I go back to the other page, tail will probably be in here. There it is. The tail W is an action that produces the output W. So it takes the W, yeah, so it looks like it puts the W in to the writer, except that's writer T, but it'd be just a writer. Okay, that's fine. So when we tell, because I'm telling on you, where is it? Yeah, we're basically popping into our there, we're putting 1. Cool. And then at this point, we take 9 of the input. Yeah, so we're taking 9 from the input, so that just returns us like one thing. So func4, so look what func4 does. There it does, oh okay, and there it just puts in 10. So at this point there's 1, and then func4 is here. Again, that's in the writer. If it's less than, then that just, I guess the writer just overwrites it. I don't think it's actually, it doesn't seem to be accumulating it as a monoid by the looks of things. So, oh okay, maybe it does. Notice we no longer need to actually explicitly keep track of the accumulator. It is now wrapped by the writer monad. We can increase it in any of our functions by calling tail. Oh, okay, so tail, hold on then. This is the wrong tail then, I should assume. I'm on the, there's literally 2. Is this just a writer? Oh no, it's not, that's writer T. Oh, but there's writer here. Oh no, okay. That is writer T. So let's have a look. Go away. Is there, I saw the other day. Oh, you can do this. I didn't know. What? See that? You can literally press. I saw this the other day and I was like, how is this? And I've just worked it out. So if we do, look, you can search this whole file. But the type writer W is writer TW identity. Oh, okay. So writer is using that. Is that the same? Oh, I don't know. Anyway, that was W. There we go. There we go. This is what I want from Transformers. Cool. Oh, okay. Oh. No, we can't. Oh, it's lazy. Okay, okay. Can't win. It's still the identity of writer T. The return function produces an output empty whilst combining the outputs of the sub computation using mapend. So yeah, every time you're doing a tell, you're map ending a new value onto it. It looks like, which is, I'm looking at the code on that side, but really it's on here. Yes, every time we do this and this, it's map ending an extra value to our int there. So that's how come it's able to accumulate them. Yeah, that makes sense. And then, so here, all of these just do that. They accumulate, because this does also, that does some accumulation by the tails. But it's here that then we run it to find out the information of what's coming out of it. And then here it looks like, yeah, we're grabbing that. I said, I should import it, because then we could sort of do type holes and find out what each value is, but we get the idea. And the other thing is, you don't want to be reusing writer. It's not that good. I mean, why is it? I don't even know why it's not. I've just, from reading it and people just saying, yeah, don't use it. If you know, if you're going to readers, okay, writers are like, it's, well, from the point of things, it seems a little bit dangerous, isn't it? It's just sort of continuously map ending stuff. And there's sort of nicer ways dealing with that. Okay, so it's much simpler, and our code types are clearer. I guess it's simpler, but is it really? I mean, you have all this stuff all over the shop. But is it clearer than this? Yeah, I'll give them that. It's definitely clearer than this, isn't it? Okay, so conclusion. Now that we know about reader and writer monad, it's time to move on to part 5. And we'll discuss state monad. There we go. That's a better one. Don't use writer, just use state. So we'll move on to number 5. Here we go. State monad. And this is just how to get started. Blah, blah, blah. Oh no, it does say something. It's different this time. So we learned about reader and writer monads. These gave us a new perspective on Haskell as a whole. Yeah, I guess it. Yeah, maybe it did. Yeah. It's kind of like how to handle some form of state. They showed that in fact we can have global variables of some sort. We just need to encode them in the type signature somehow, and this is what monads are for. In this part we'll explore the state monad, which combines some of the functionality on both these concepts. Cool. Once you understand state, you'll be well on your way to being a Haskell pro. Yeah, I reckon, to be honest, you know, once you get like state, you can easily be doing stuff in production. So this is, I guess it's like, well, it's not advanced, you know, it's not like a brain, whatever you call it. Where is it? It's this one, isn't it? Let's find it. Have I got it on here? Oh no, I don't. Haven't I got? Oh, I don't have them all switched on. Okay, never mind. There's a way to like turn on. Oh, I've got this though. Sorry, I'm just like doing something totally different. I've got access to that, I guess. Never mind, can't win them all. Okay, motivating example, Monopoly. For this part, we'll use a simple model of Monopoly-like game. The main object is the game state, data type containing several important pieces of information. Cool. Okay, this is a little bit more exciting, isn't it? What are we on here? This is state. State monad. Cool. And then we're going to have this Monopoly. Okay, so we'll copy these data types. And we'll quickly go through them. Oh, look. See. Bam. Missed that. Okay, so... Oh, don't worry about it, Vince. Just leave it. There we go. So we've got a game state, and inside of that game state, we've got its constructors, which are a list of players. Players is a list of players. A change deck, oh, excuse me, is a list of game cards. This isn't going to work because we haven't. Oh, okay. So, yeah. So should we just pretend like that they're just ints? Should we just do? No, we'll just do whatever. Let's just pretend. I've got a feeling that I'm writing this stuff out, but really it's not going to be used. So I'm kind of wasting time. But let's just do it anyway. So we'll say, what should we make this? Change card. I don't think it's going to go well. let's just string player. I don't know. It's gonna be a string as well. Board position. It's gonna be a string as well. This isn't gonna work. I can tell already because clearly board commit position is not just gonna be string, is it? Game action. Yeah, definitely a string. Right. Anyway, types have passed. It's fine. Ship it. That's what they say, don't they? Oh yeah, I was like, I went on for the first time in a long time. I went on Reddit yesterday. And like, yeah, God, that place. Whew, it's not the. What, you're not happy? Oh, look at that typo. It's a dot. Should be a comma. Yeah, and I think someone had done a blog post and it said, you know, something about oh, what's happened here? Multiple declarations of string. Oh, okay, hold on. What have I done? It'd be like this, wouldn't it? Derp. Is game action? Yeah, we can just do that. Yeah, so anyway, I went on there and someone had done a blog post and someone else was complaining, saying that there was they had enough of people saying that if the types check, then it's good to ship. And it's just like, I don't know, people are so anal, aren't they? It's just like, whatever. If, you know, it's not like I mean, you've got a fairly good certainty. Yes, of course, it's not going to be 100% because you're going to get edge cases and you have to catch those. But compare it to a lot of other languages, I'd feel a lot more confident, you know, putting a piece of Haskell software out without any test than I would other languages. I mean, and also I'd say pure script because I've done that as well. You know, because you've got a strongly typed system, but like I say, it's not going to catch all the edge cases. But there's so much crap code out in production, just, you know, don't even have, like, I've been at places with JavaScript stuff. It's just unbelievable, 0 tests. So I mean, for then someone to turn around and go, well, this is not actually technically true. So it's like, shut up. But I went on there because I'm doing the other series, which is learning Haskell from scratch. And is it learn for Haskell? Yeah, for yeah. So this repo here, and I do this in another stream, well, in this stream obviously, but different days. And Veronica and Dimitri, and they've got some people like they did a calendar thing, you know, like the advent calendar vibe, and they were doing a Haskell one. Like, great. I mean, they do this in itself is bloody great. They're inviting people to learn Haskell and well, just, you know, to be able to start from scratch. Yes, it's you know, potentially connected to Hacktoberfest, but I don't think they were doing it out of malice. They just wanted to get more people interested in Haskell. So first, I think they got a bit of crap because it was to do with Hacktoberfest. Like, get over it, whatever. You can still do it. You don't have to get the T-shirt, and you don't have to keep you know, doing pull requests with a typo change. Do you know what I mean? I think their aim for number one, so they got a bit of crap off that, which was like, okay, whatever. And then they did try to do the advent, and then some other people on Twitter and stuff would just give them shit, and it's just like, why you give, you know, these people were like, and they've created this repo, I'll add because it needs to be added, and they're basically saying, create a fork of our repo, do your own PRs onto your repo at us, and we'll, you know, if you're running into troubles or anything, at us, and we'll help you. And I mean, and I think I saw them, they're saying, oh, they've still got like another 50 to do. You know, I've offered like to try and help them out or whatever, but it's, you know, so they're doing all this stuff for what? For free? And then they're getting like shit off people from the community. It's just like, shut up, you know, just fuck them. That's what I said. Don't worry. So I do this, and if people give me crap, I just tell them fuck off. It's just like, I don't care. I'm just doing it for my fun, and hopefully other people could learn. If you're not happy, do one. There's plenty of other channels you could go watch. And do you know what I mean? Go watch some gaming or something. Or, you know, I think I had someone complain about on a, because it's a lot harder. I used to do YouTube videos, and they're a pain in the arse because you have to edit them and be really specific. And someone was like complaining about my audio, and so I just told him, turn your headphones up. You know, what do I care? You got, you know, doing anything open source and things like this, it's a twofold thing. You have to be a bit selfish with it. in terms of like you have to enjoy it yourself. You can't just be, outright giving, because then it's just going to bite you back. And then if you, which is a shame, and especially like given the current situation, if you're sort of potentially stuck at home all the time and you're gonna, you're putting stuff out and you're hoping for a positive response, and then all you're getting is just a bunch of knob ends, then yeah, it's gonna really bring you down. So it's just like, I don't know. I just found that and I thought, sods, that's not very nice, is it? So yeah, just wanted to say that, by the way. Sod off. Get people actually pushing, because those guys are they're attracting new people to Haskell, and that's what it needs. We need to sort of move away from this academia language, because it's a fun language and it is cool to do, but yeah, when you've still got, and it's like anything, it's the same in sciences. They say it takes a generation to kill an idea. That's for the people that think that the original idea are dead, basically. So once they're dead, new ideas come upon us. So I don't know when that transition is, but yeah, I think it's coming. That's what's happening. But I don't know. There might be, it's like any language, don't you? It's like anything, really. It's not just Haskell. It's everything. You always get a knob end, don't you? Anyway, let's go back to this. So we were doing. Let's move it up a little bit. There we go. Is that my laptop going mental? Yeah. I think it's something else as well. Are they drilling outside? Right, should be doing some coding. That's what we're here to do, aren't we? I think it's let's have a little listen. Out the headphones. Oh my god, my laptop's going mental. You're taking off? Just started. Alright, laptop, chill out. 3.5 grand, worst laptop I've ever had. MacBook Pro, 2019. Piece of shit. Sorry. I've had loads of MacBook Pros, but this one, it's been the worst. Okay, so we're looking like we're setting up some sort of data type for a game state, and then these are going to be extensible. Well, they're going to be extended. So I guess like a player would be like name, age, whatever. But I've just stuck it to string. Let's think for high level about how some of our game functions would work. We could, for instance, have a function for rolling the dice. This would output a number and alter our game's number generator. We would then make a move based on the dice output and the current player. Yep, this would change the piece position in the board state, as well as leaving us in an output action to resolve. The output action would be something like drawing a card or taking action on a property. Blimey, yeah. I mean, we're clearly not going to be doing a state monad here, but let's keep going. Buying a property also changes the board's state. Drawing a chance card would update the state of the deck whilst returning us a game card to resolve. Okay, we see a common pattern here among the different action. Almost all of them will update game state in some way. Yep. And some of them will have additional pieces of output we'll want to use. Okay. So the state monad. This is exactly the situation a state monad deals with. The state monad wraps computation in the context of reading and modifying a global state. So yeah, in general, that's why I was saying before, you're not going to use the writer monad as much, because you might as well just use a state then, because then you've got the power of both. Yeah, that's generally what happens. This context change two operations together in an intuitive way. First, it determines what the state should be after the first operation, then it resolves the second operation with a new state. So much like the rest of Haskell, you're not technically like oh, that was a funny noise. I forgot what I was saying. You're not something technically doing. Yeah. Reading and modifying a global state object. Yeah. This context changed two operations together, and I've just thought about what that noise was. It's probably my bleeding cat. Right, well, we'll just... Cat, stop being naughty. I think the other day she fell off the top... what did she fall off? Top of the cupboard. She thought there was a box up there. She tried to get into it. Fell off. This context changed two operations together in an intuitive way. First, it determines what the state should be after the first operation, then it resolves the second operation with the new state. Yep. So it parameterized by a single type parameter s. Actually, we go look quickly on this one, shall we? There we go. There's the s. Let's have a look. And then we've got on the state monad, we've got a constructor which is run state, and then we can. It's a function takes an s and returns us s and the a. What does that mean? We'll see. After the first operation resolves, it parameterized. So just like reader has a single type we read from, the state has a single type we can both read from and write to. So that's different, isn't it? If we compare it. Yeah, so we can both read and write on that one. Whereas if you use reader or writer, then you're having to use them both separately. But here you can just use them together. The two main functions we'll use within state monad, which are get and put, which I guess the name is pretty damn obvious what they do. They get it and they put it into the monad. They do exactly what you expect them to do. Yeah, you'd hope so. I'd have been a sod and made him. No, actually, let's not say well, yeah. Okay. So the get function works much like the ask function of the reader monad, retrieving our state value. Meanwhile, put works similarly to tell in a writer monad. Yeah. So instead of having two different monads, you can just have it in one, and then you get a put and get and put rather than ask and tell. Right. Finally, we observe that there will be a final return type of each expression in state, just as there is in any other monad. Thus, our different functions type will look like a return type of A. Okay, so state, game state, A. Oh, okay, so that's sorry. So it's basically type will look like the return of type. Yeah. So you know, like we had in our previous one. It's not there, but it was like a writer, and then the state, the type of the state, and then an A. So it would have been an int. For this one, it'd been like string. It's the same thing. So it's state, game state, and then A, whatever that happens to be. So there we go. Look, int. So now we can examine some of the different functions mentioned above and determine their types. We have, for instance, rolling the dice. Cool. So state, game state, integer, do. So straight away, because we're in a state monad, okay, so only when you're in a state monad, when you do a get, you're basically grabbing that out of the state monad and then binding its value. So if we look at, where's the get? Oh no, use this thing, S, get, except it doesn't work very well when you've got a small screen. You're not finding it. Oh. Okay. Well, is it get? Hold on. Have I just? Yeah. Okay. Well, I don't know. I thought I was in. Oh, maybe I'm not. Not the right one. Not the right one. New type. Oh, okay. There. I was in the wrong one. Probably why. Where's get? There's get. There's get. Woo! Okay. Fetch the current value of the state within the monad. Cool. And then when we bind out of it, we actually get that value. So here. Let me just turn this down a little bit. Whatever. Yeah, so when we do get there, we actually get that value. So that would be the game state. So at that point, it's the state game, and then by that point, it's game state. Cool. And then here it's just run some random generator on the current state. And then here it looks like, oh yeah, it's just doing some random numbers by the looks of it. Yeah, between 1 and 6. So that's for rolling the dice. Dirt. Clearly. And then once we've done our computations, well, we want to say that within generator, so actually we can just look, we had generator type here. Yep. So we can return current state. Oh, okay, so that's current state. Yeah. So what we're saying is we're grabbing generator out of current state here, which is our generator. So whatever that happens to be. Oh, it's a standard generator. Cool. So we grab that out, and then we generate some random dice rolls right there. Yeah, between 1 and 6, and then so we do it twice, and then we return. We put the current state, and we override whatever the generate was before. Okay, so that overrides it, and that's what's in the state now. The generator is saying we've stored that, and then here we return D1 plus D2. Cool. Oh, so you roll 2 dice like that. Boof. Cool. That's pretty handy, isn't it? And then yeah, we're so if we have a look at that quickly. Actually, can I just like this? You gonna work? You're gonna work. You're gonna work. Work. Here we go. Oh. Yeah, I shouldn't have saved it. What was I expecting? I mean, this is like generating random numbers, but okay, yeah, it's just a data type. Yep, that's fine. I thought it was going to show us more for some reason, but cool. This outputs an int. Yeah, so we can see that obviously D1 and D2, that's going to be a random number between 1 and 6, and that's going to be a random. So actually, if you look at the type of random R, that'll probably be S? D, S. Random R. Random R. Random. Is that what it was using? Yeah, that's a function. Okay. We'll open another one. I'm really going for it now. There we go. So it returns us. Okay, so it takes a range of low and high and pseudo random number generated G. Yep. And returns a pseudo random value uniformly distributed over closed interval. So if we look, that returns us our generator and the value. Okay, so we're just saying what generator. So because when you're doing random numbers, the generator, if you use the same generator, it's going to constantly be the same value. So you could just do 1 to 6 and with one generator, and it'll just return you the same value continuously, which is not what you want when you do random numbers. Yeah, can you see? Look, so it's like it takes in the generator from state, which is just gen, and then it passes it along here, and then it converts it to a new one, passes it along, and then it returns that, and then it will do it again. But then every time we're doing this set of actions, it's new generators. We're not using the very first one. But if we were to just say make that a random generator here and just use the type of the standard gen, then we'd be in trouble. Unless you always wanted to roll 6 or something throughout. Well, whatever you roll throughout the whole game, it'd be the same numbers. Cool. So that's cool though. So I guess this will be a number between 2 and 12. Yeah. So that's what it returns. And then here we're always passing. That's why we're passing a generator around, so we can reuse it when we roll the dice again. This outputs an int for us and modifies a random number generator stored in our state. Now we have the function for making a move. Cool. Move piece. So that would take a player, an integer, and again the state. So we get a player and a roll. So the roll, I assume, would be the result of this, and then the player would be whatever the type of player is. So from here we'd get the current state, and we'd get in the piece position. So we'd find out where is it? Piece position. There. So it'd be that's a map. Okay, so it'd be a map of the player, whatever the player type would be, and a property. Okay, so maps are like key value pairs. So the key would be a player, and a property would be value. I just said what it was and I forgot what it was. Cool. So that's really handy. You can like do lookups by the player, etc. So I guess that's what it's doing. So here we're getting the piece position, which is the map. Oh, there we go, look. And then we're doing a lookup. So that's what a lookup is. So we're doing a lookup of the current player. Where's the... Yeah. So that's the inputs. So we're doing a lookup of the player. It's exactly what I was saying. So we can look up the current player and get its current position, which is that. So from the map, sorry, it's taken... We're saying... Yeah, I should call it current positions map. Oh no, it's got an S. I guess that's fair enough, isn't it? So yeah, so we're looking up the current player using the map. Okay, so then that returns a current position. So this is like really cool because at this point we can have, our piece positions can store every player on the board and attach the player with the property. So and then when it comes into here, move piece, it's abstracted the fact that it can use, it can just find any player doing a lookup, and when you're doing a lookup on a map, it returns a maybe, so nothing if it doesn't find it, and just whatever. So hence you do the from just. And then next, which is the next property, current position role. So where's the next property? I guess that's another function. Oh yeah, okay. So that's just basically saying, take our current position and then what are we going to do next? And then once we've done that, we want to reinsert that into the player. Yeah, which makes sense, doesn't it? Yeah. Oh, sorry. We want to reinsert that into the player. Yeah, so if we look at insert, actually. I keep going to the top. I should just press that. Just in case we don't know what insert is. I mean, I guess we should, but we might not. Insert, is it int map? Foldable. Yeah, date map. Except, yeah, okay, here we go. So we take the key. Oh, it's just on an int map. Okay, well, let's just imagine this is a map. Let's not imagine. Let's just look for it. Date.map. This looks more like it. Here we go. Yeah, cool. Oh, and it exactly shows you how it works as well. Yeah, so if you insert the key, the value, and then into the map, and then what it does is if that key already exists, it overwrites it. If it doesn't, it creates a new one. And then if you look at the results, and if the map's empty, then it just creates a singleton of that. But yeah, and then this basically shows you that it overrides it, or it creates a new one if it can't find it. Cool. So that's that. So yeah, it looks like basically then we're inserting the new map, and then we're putting it back into state. Sorry, it'd be here, put, and we're putting it back into state, and then we'd return next, which is, what's going to happen next in our game state. So that's pretty cool. We're basically able, so we can see how we're getting stuff out of current state, putting them back in, using the map to, to work out our next positions of the player, blah, blah, blah. And if you imagine you were trying to do that without the state monad, I don't know what you do really. It'd be pretty damn complex, I'd imagine. You'd be pretty stuck, that's for sure. So next, what is it? Yeah, still, come on, computer. Has it calmed down yet? Ow! There's a microphone there. As time goes on, the computer gets quieter. Does that make sense? Probably not, but I'll take it. So this will give us an output of a new property we landed on, while also modifying the board of our new position of our piece based on the resulting position. We might take different actions like drawing a chance card. Yep. And draw a chance card, get current state again. Excuse me. Chance deck. So chance deck is there. So that's like a set of cards, I guess. And then that will return us a list. And then we take the very first card, which is the top card. And there we return the first card, and then because we've taken the first card out, we return a deck. I guess technically you'd probably want to append it to the end and then return it. So so it's like putting it back underneath. But never mind. As we said above, this will modify the pile of available cards in the chance pile. There are other stateful functions we could describe, such as resolving a property purchase or paying rent to another player. These would exist within the same state monad. So yeah, you can see, and then if you just adjust something on the state monad and then you don't expect that function to return you anything, you just put unit. So if you've got functions that specifically are just going to adjust a bit of state and not do anything, then your return type of that function would just be unit. So if you were to have it in a do block, say you'd get something, and then at that point you just want it to do something else, then you'd pop it in, and then it'd have no return. So finally we can combine all these functions together with do syntax. Here it is. This is like the bit I was just talking about. And it actually looks quite clean. We don't need to worry about the side effects. Different monadic functions handle them. Here's a sample of what our functions might look like to play one turn of the game. Cool, so resolve turn. So we'd get the stuff. So you can see, look, this is a unit. So this function is just going to run all the stuff, but it's going to return unit. Okay, but which is like when you do return, if you remember from previously, return just wraps whatever we've got in our current monad, which here is state monad. Cool, so we'd get and then from there we get the current state. So we get current player from the current state. So in case you didn't know, when this would be of the type game state, and then when you put the value of the constructor in front, which is current player, which isn't there. So I guess current player grabs it. Okay, well, the other way anyway. If you were to put, say, player, that'd grab you the list of player. But I guess that's going to be another function that actually grabs the current state of the player. No, it moves it. Okay, so player to move, and then roll the dice. I want to become famous by followers. I can't. Yeah, I do. I'm going to say it. Yeah, please. Right. So if anyone wants to click it, well, on your head be it. I don't know how to delete it. How do I delete that? Don't know. Chat settings. Switch to non-mod settings. Yeah, don't know. Can't get rid of it. Sorry. Don't click it. Don't click it. Don't click that link. Want to become famous. On Twitch. Yeah, I guess so. I guess it's like YouTube, isn't it? People want to get famous sitting at home. Which is probably pretty good at this time and day. Blah, blah, blah. Yeah, so here you can see basically it's just doing all of our functions that we had that also use a state monad, and returns it. Resolve action, switch to next player, and then return. And I assume switch to the next player, go on and do this again. Yeah, so we haven't described all these functions, but the general idea should be clear. They would all exist within the state monad. Yeah, so anytime you use a state monad, all of these functions will live within it, and then you'll be able to mess around. When thinking about Haskell, state, IO, and other languages. When thinking about Haskell is often seen. I'm doing like a Savna. When thinking about Haskell, it is often seen as a restriction that will have global variables, like you could within Java class variables. However, we see now this isn't true. We could have a data type with exactly the same functionality as Java class. We could just have as many functions that can modify the global state of the class object using a state monad. The difference in Haskell is we simply put a label on these types of functions. We don't allow it to happen for free. We want to know when side effects could potentially happen, because knowing when they can happen makes our code easier to reason about. In Java class, many of the methods won't actually need to modify the state, but they could, which makes it harder to debug them. In Haskell, we can simply make these pure functions and our code will be simpler. So basically it's saying that we can isolate where, we can be explicit, or we can be like, we can determine exactly where these manipulations are going to happen, and then you can find the source of the manipulation of the state. Rather than having all the functions have access to it, every function, and then not knowing exactly where it's going, because we've got, we've had to explicitly do things like get, which at that point we go, oh, okay, well this one's definitely getting something from the state. Okay, so we're gonna load it up. Yep, but they could, which makes debugging them harder. In Haskell, we can simply make these pure functions, and our code will be simpler. I/O is the same way. It's not like we can't perform I/O in Haskell. Instead, we want to label the areas where we can to increase our certainty about the areas where we don't need to. When we know part of our code cannot communicate with the outside world, we can be far more certain of its behavior. Yep. So that's essentially, any sort of computer programming. The idea being is, what with Haskell is, the outside world is the unpredictability. Within our program, we can be predictable in terms of like we can sort of determine what is going to happen given certain circumstance, but that given circumstance comes from the outside world, which is where so that might be reading a database, or anything where it's not actually internally. Then we sort of use monads and things to wrap around it and say, hey, by the way, this is the outside world, we know it is. And you'll see a lot of times when you do sort of do those computations, sometimes they'll just simply wrap it in if it's got like a nothing or something, and it's like, no, well, that didn't work. So then from the get-go, you've your outside computation is almost protected. It's not just going to happen and then you hope that because a lot of languages just rely on the fact that it will happen, and then the only way to sort of check something hasn't happened would be like null. And null checking isn't that powerful, because you can have, especially in things like JavaScript, you can have multiple nulls but here we can be pretty damn explicit if something fails and for why. Especially when we saw before, if we do things like the even monad, then we can even pass along errors. But anyway, that wraps it up for the state monad. Now that we know all these different monad constructors, you might be wondering how we can combine them. This is the bit, but I reckon I'm going to call it a day here, because I don't even know when I started. Don't know, some time ago. Yeah, I'll probably cut it short here, but it's probably a good time to stop. So combining them together is exactly where monad transformers comes about, because we're combining the monads together. That was a reader. Hold on, wait. What if there's some part of the other state wondering how to combine them? What if there was some part of our state that we wanted to be able to modify using the state monad? But then there are another part that was read-only. How can we get multiple monadic capabilities at the same time? To learn to the answer, head to part 6. In the penultimate section of the series, I'm going to leave it on a cliffhanger, we'll discuss monad transformer. This concept will allow us to compose several monads together into a single monad. Now that you're starting to understand monads, you can really pick up some steam on learning steam, not stream. Stream's what I'm doing. Steam's what locomotive engines do. On learning some useful libraries for important tasks. Download our production list. Oh, in case, here we go. In case you want to go over this stuff, because I'm literally just taking it off there. Oh, have you just come on? Oh, no, what? I don't know. Oh, the end? Or no, we're there. No, something. There it is, monad transformer. The suspense. Oh, yeah. It's like the cliffhanger. It's like a horrible, dirty soap, and I'm leaving it on this. Look at it. I'm teasing you. In tomorrow's episode, I don't even know if I'm going to do it tomorrow, but in the next episode, monad transformers. Motivating example, triangle of doom. Okay, I'm going to stop there. Cool. Well, thanks for joining. And hopefully see you next time, whenever that might be. Oh, hold on. I still haven't done an outro. You know, like the pros. I have an outro screen. Well, I don't have one. Sorry. I might make one. I've made another cool little. Oh, I can't show you. Can I? Let's have a look. I've made like another little. Where's my GIF? Oh, I haven't got it yet. Oh, look at this one though. I need to add this. I don't know where I'm going to add it. But that needs to go somewhere, doesn't it? Like a boss. That's basically my cat, except my cat's the female version of that. Tune in next time. Yeah, I can't find it. I've done a new thing. Because that's how exciting I am when looking for work. You end up making GIF animations. Yeah. For more Transformers. Tune in. Right, anyway. I messed up. Cool. Thanks for tuning in. Oh no, I need to wave at the camera, don't I? Not just like up in the air. Thanks for tuning in, everyone outside. And see you next time.